It's important to be able to come up with the equation of the line, given that we've got a line and we're told certain bits of information about this line. So you need to be able to come up with the equation that describes this line. It's called a mathematical model. So the way we do that is use a rule that says that y minus y1 equals m outside of x minus x1, where x1, y1 is a point on the line, and m is the gradient of the line. So given that we've got one point and we've got the gradient, there's only one line that can be drawn like that that goes through that point with that gradient. If you just give me one point and don't give me the gradient, I can draw an infinite number of lines that go through that point. If you just give me the gradient and you don't give me the point, I can draw an infinite number of lines that'll have that gradient. So what we need is to be able to work out, or if it's not already given to us, the point on the line, and then we need to be able to work out the gradient, or that may already be given, and so we can substitute in there and come up with the equation of our line. So let's just do two examples that might make that a little bit clearer. So we're asked to come up with the equation of the line, given that it's got a gradient of -1/2 and it passes through the point -2, 3. So if we were to sketch it, it's going to go through -2, 1, 2, 3. So it's going to go through that point there at -2, 3. And it's got a gradient of -1/2. Now, -1/2 means it'll drop as we go across the page. And so for every 2 it goes across, it is going to drop 1. So it'll actually go through there as well. So for every 2 it goes across, the -1 means it drops. So here is my line, and I want to know what equation will describe that line. Okay, so if we start, so we've learned our rule up here, m outside of x minus x1. If you write it out every time you do one of these questions in the tute, you'll remember it. We need to define what is what. We need to know the gradient, and we need to know one of the points on the line. Well, this tells us both. So here, this is my m value, that's the gradient, and this is my x1, y1. Okay, notice that it's a subscript. It's not x1 with the 1 on the same line as the x. The 1 is just down a little bit below. So x1 is -2, y1 is 3. And now it's a matter of just substituting in. We don't substitute for x and y because they'll be in my final equation of y equals mx plus c. So y minus, now the y1 value, instead of that value there, y1 is equal to 3, equals m. We've identified that m's -1/2 outside of x minus, now x1, very careful, it's x minus x1. Now x1 is -2. Okay, it's probably best to simplify minus. If you subtract and then subtract again, you're actually adding. So -1/2 x plus 2 equals y minus 3. I would remove brackets. I'm going to give my answer in the form of y equals mx plus c. So I've got to get rid of that -3, but before I do that, I need to remove this bracket. So that -1/2 has got to be multiplied by the x, and the -1/2, so plus -1/2 times 2. So the -1/2 has got to be multiplied by both, and that's y minus 3. So y minus 3 equals -1/2 x. -1/2 times 2 is -1. And then when I add 3 to both sides, I get y equals -1/2 x minus 1 plus 3 is plus 2. So that is the equation of the line that passes through -2, 3 and has a gradient of negative a half. Well, it certainly has a gradient of negative a half. So this is the equation of this line here. And just by the little bit of working we did, starting at the point negative 2, 3, we knew the gradient for 2 across, it dropped down. So we could see that that was the point 2. So it certainly has a y-intercept of plus 2. We could verify that this point is on the line, because if I put the x value of this point up here, I should get the y value. So x equals negative 2. We know this is a point on the line. We get y equals negative a half times negative 2 plus 1. Plus 2, sorry. Negative a half times negative 2. And negative times negative is a positive. The 2's will cancel. So we get negative times positive. Positive 1 plus 2, which is equal to 3. And that is the y coordinate when x is equal to negative 2 from what we're given up there. So that's just verified our answer. Let's have a look at this one over here. Well, what are we given? We want to use this rule, and we can make either one of these our x1, y1. So why don't we do this one? We'll make this one our we'll make this one x1, y1, and I'll make this x2, y2. Okay. So we've got a point on the line, but we don't have a gradient. Now there is, if you've got 2 points, x1 and y1 and x2 and y2, if you've got 2 points on the line, then this from here to here will be that x coordinate minus that x coordinate. So this is x2 minus x1 from there to there. And from here to here will be y2 minus y1. This is my rise, and this is my run. So if gradient m is rise over run, it's y2 minus y1 over x2 minus x1. Now once again, that should be memorized. You should always remember that. But if you've got 2 points, notice that they're both, you start with the same number, y2, x2, take. It's always take, y1, x1. So changing the x is my run, changing the y is my rise. So I've got 2 points, so I can actually work out what the gradient is. So I'm going to substitute in y2 minus y1 here. So y2 is 2 minus y1 is 1 up there, over x2 is 3 minus y1 negative 4. So 2 take 1 is 1 over 3 minus a plus, 3 plus 4 is 7. So my gradient is 1 over 7. So I've had to do an extra step here. I didn't have the gradient to start with. So now I can quote my rule, y minus y1 equals m outside of x minus x1. Y minus, now my y1 I made as 1 equals m is 1 on 7 outside of x minus negative 4. So that's equal to 1, 7, x plus 4 in brackets, y minus 1. Remove my brackets before I take the minus 1 over, so I get 1/7 x plus, now 4 is like 4 over 1. I am multiplying 1 on 7 by 4 on 1. Multiply the top, so I get 4 over 7. And then I add 1 to both sides, and I get y equals, so minus 1 plus 1 is y, 1/7 x plus, now 7 as something over 7 is 7 over 7. 7 over 7 is 1. So I've got 4 over 7 plus 7 over 7, which will be 11 over 7 when I add the fractions together. Okay, so there's the equation of a straight line that passes through negative 4, 1 and 3, 2. And this one over here, I'll add the beauty of already knowing the gradient, and we just add that point as a point on the line.